So let me move quickly on to my presentation. And first of all, let me start with a quote. And that quote is from one of our financial services customers, Underwrite.ai. And Mark Steen, their CEO, came with a statement that read, "Not only can we reach a decision, we can also explain the decision, be fully compliant with the regulators, and it takes less than half a millisecond." If you can't use machine learning to make an operational decision that is both accurate, can be explained to external stakeholders and regulators, and do that quickly, no organization is going to be able to maximize the value that machine learning can actually make. The key with machine learning is to do that quickly, to do that accurately, and also to do that in a transparent way. What we're seeing in the is artificial intelligence and machine learning now going mainstream. Everywhere we look, someone is talking about machine learning. It's creating headlines around the world with huge amounts of media buzz. Machine learning techniques primarily learn from data, make predictions, and allow us to improve products that can really look to enhance business decisions. However, there's an awful lot of hype and also misconception about what it can do, and also really what it can deliver as well. And the key with machine learning is that it's only useful if it can create business value. And what we'll be looking at in this webinar is how does machine learning create business value for financial services. It does offer a huge amount of opportunity, but it does also create a great deal of complexity. Going from data to value is incredibly hard. There are so many different technology choices that you as organizations currently face. There's huge amounts of confusion about how quickly we can go through this, how different products compare to each other, what the value is of different technology solutions, people and processes. And I'm pretty sure that many of you are stuck in this maze of data to value and struggling your way out of it. And the challenge that you have is that the complexity is just providing a barrier to that data. And what we want to do here at H2O is to enable you to quickly navigate through that maze. Allow you as a financial service organization to really understand which segments of customers are you going to target with what product. Enable you to quickly predict which transactions are going to be fraudulent. Work out how much should you charge a customer for a service. And in my 2 decades of applying machine learning across a number of different industries, I really find that organizations get lost in trying to get to grips with the technology and the process around it, rather than really focusing on how do we quickly drive business value that allows us to increase revenue, save cost, and also improve the productivity of our workforces. If we then have a look at the value, really the value that we're looking to create in financial services is actually threefold. It's first of all looking at revenue growth and looking at use cases that allow us to drive significant revenues for our organizations. So use cases around customer value modeling and customer churn reduction. The second area of delivering value is around cost efficiency. How can we manage operational costs through better capacity planning and automation with machine learning at the heart of it? How can we offer financial control through maybe portfolio simulation? And then finally, how do we control risk? How do we better manage risk losses through better risk underwriting and better credit risk assessment? How do we look to prevent fraud losses through better fraud detection systems and anti-money laundering applications? These three pillars really are the things that allow us to drive value. But what is stopping us doing that in a machine learning sense? The things that are really stopping us are threefold. Sometimes just one of these things constrain us from maximizing revenue and decreasing cost, but sometimes it's a combination of all three. To gain the true value, we need to make sure that we're focusing on these three key elements. Those key elements of speed, the speed at which we process the vast amounts of data that allow us to build these machine learning models, that allow us to automate the prediction of outcomes. We need to be moving the speed down from weeks and months of building machine learning models down to seconds and minutes. We need to look at improving the way that we move our models from a development environment into a production environment. We also need to make sure that we're gaining value by really focusing on the accuracy of these models. We need to make sure that they truly reflect the patterns that we have in our data. We need that to enable organizations to gain trust in these machine learning models that we're building. But we also need to establish these trust by making sure that these models are transparent, to make sure that everyone understands how the machine came to that decision. How was the model built? What are the key driving factors of that particular model? And in the past, organizations have had to sacrifice one, two, or maybe all three of these to deliver a form of value. As data has increased and compute costs have come down and machine algorithms have come out of academia, all of these levers can now be maximized and therefore optimized. The advantage that you have with machine learning in financial services is that they can be applied, or it can be applied to a whole range of different use cases. And what I've got on this particular slide is a summary of all of the use case, or a lot of the use cases that H2O have worked with our customers to look to solve. Problems around fraud detection, problems around risk modeling and creditworthiness check, problems around customer lifetime value prediction and recommendation, challenges around customer segmentation, as well as other use cases such as image recognition, natural language processing, and video analysis. All of these driving value to our customers. But what do all of these use cases really have in common? Well, they all have what I see as 5 elements of fuel to the fire. What they all have is have the same recipe and the same basic ingredients to them. Those basic ingredients being, first of all, data. Machine learning cannot thrive without data. And financial services organizations are overwhelmed with the amount of data that they have. What also drives machine learning is basically clever maths, whether it be machine learning or deep learning or the next iteration of artificial intelligence. Underpinning that is maths. fairly complicated maths, mind you, but at the end of the day, maths. The reason that these have really come to fruition on large amounts of data is because now the computational power that we've now got available, whether that be on premise hardware or using a cloud environment. But what we also need is a business problem, a problem that an organization currently has, and if solved, will deliver significant value. But also what is required is domain expertise. A lot of the challenges organizations find is that they want to apply machine learning to solve a particular problem, but they then don't involve people that have got an expertise within that particular domain. They can really add value into the solution to understand the pitfalls and maybe the regulatory constraints that the business will be under if applying machine learning to solve that particular problem. But if you've got all 5 of those, you can really gain massive value from machine learning and artificial intelligence. I like my quotes, and here's another quote from Gartner. So Gartner in 2019 said, "Today, the availability of data scientists and machine learning experts is extremely limited, and this state is not likely to improve in the near term. The use of artificial intelligence to build artificial intelligence models is increasing the ability of enterprise employees to create models that add value to applications and data in the business." And this is what we're also seeing in the marketplace. Lots of people wanting to build machine learning models and gain value from artificial intelligence, but not having a workforce that allows them to do that. Here at H2O, we're on a mission to really democratize AI. And we're doing that through a combination of open source technology as well as commercially licensed software. Currently, we've got over 14,000 companies using our products, which is the equivalent of probably about 155,000 data scientists using our product portfolio worldwide. And the products that they're using really fit into 2 camps. Everything on the left-hand side that you see here is open source, and what you see on the right-hand side, driverless AI, is a commercially licensed product. And the reason that we've got 3 open source products is because we've been doing machine learning since 2012 on large compute environments, and the back end and the technology has evolved over time, and our technology has evolved with that. So H2O, our initial open source package, was released to run across Hadoop infrastructures and distribute machine learning across that Hadoop estate. What that enabled customers to do was to move machine learning from a very slow process on small amounts of data to accelerate that model building process to run in minutes across billions of rows of data. In 2014, though, we saw a change in organizations wanting to gain power from machine learning, but to do that across Spark infrastructure. However, there were inefficiencies in Spark, specifically within Spark ML, and its ability to easily productionize results. And that's where we created Sparkling Water. So took the logic of H2O open source and ran that on a Spark infrastructure. And then in 2016, we saw another shift in technology with organizations wanting to utilize the power of machine learning, but distribute that workload across GPUs. What we've also done is also looked at, well, how can we automate a lot more of the machine learning process? And that's where we created a product called Driverless AI. And what I will do in the next few slides is talk about some of the examples that we're seeing from industry, specifically of financial services, of where driverless AI is really adding value to organizations around those three things. If we actually look at the life cycle of data science and machine learning, everyone's thriving for automation. But what are we actually looking to automate? Well, what we're trying to automate is this end-to-end flow. So this end-to-end flow of getting data from disparate data sources, bringing that all together into one central place, one central modeling table, or one central analytical base table, where we've got something that we're trying to predict, a target value, and things or features that we're trying to use to predict that target. We need to go through the process of which, when data scientists go through this process traditionally, is an iterative process of building models, working out what features are important, working out what manipulations they should do on the features to drive accuracy, what algorithms that they should consider to help improve accuracy. And also, and this is where really the rubber meets the road, is how do we quickly then move that model out of a development environment into a deployment environment. And what we're trying to do is automate as much of that as possible. But when people talk about automated machine learning, there's always different levels of automated machine learning. In the same way that there's different levels of self-driving cars, we have different levels with automated machine learning. And here at H2O, we really see those levels as six. So the first level is really that there's no automation whatsoever. So you do everything from scratch. You roll your sleeves up and you code your machine learning algorithms from scratch in C++. Yes, data scientists can do that, but it's not a particularly efficient way of utilizing their valuable time. So the next level of automation is, well, how do we automate the execution of those algorithms? A wide range of open source APIs. That could be scikit-learn, Keras, Pandas, H2O open source libraries, XGBoost. All of those allow us to accelerate the model building process. And organizations are utilizing a lot of those open source frameworks. As we step on to the next stage of automation, what we then want to do is how do we automate the hyperparameters of those high-level algorithms? So how do we decide how many decision trees we want to build? How do we decide what is the learning rate of a particular neural network? How do we decide how many neurons a neural network should have? As we move to full-scale automation, we want to let the data drive those hyperparameters as opposed to an individual data scientist who would just be doing that through a trial and error basis. And within the H2O open source framework, we have hyperparameterization to a large range of our machine learning algorithms, as well as that basic model selection. Level 3 really takes us, I would say, to where we currently are with the current state of technology, with driverless AI being a leading product around that, where we've automated the feature engineering as well as the feature selection. which is allowing us to really squeeze out the extra juice of our data. We've got the ability to augment our data with different data sources. And we've also got the ability to do that through not only a programming interface, but also a graphical user interface as well. And I think it's a fair reflection to say that's probably where we are with regards to AutoML. But if we're truly looking at automated machine learning, there are additional levels to hit as well. And level 4 is where we then start to consider automatic domain feature engineering. So what is it about this particular data that's residing within financial services that we should start to look at doing some specific feature engineering that's specific to that particular industry? Are there particular data sources that we know based on historical information that will be useful to solve this domain-specific problem? And then we get on to level 5, which is really the point of nirvana, where we get to the point of we just throw any data at a system or an engine, and it automatically comes up with a solution. It automatically solves really hard machine learning problems without any input or guidance whatsoever from a human. In fact, that interaction that the human has is rather than fingers on keyboards, it's a full conversational interaction with a human user. We're not at that point yet, but that's the vision of H2O, to move from the level 3 to the level 4 to the level 5 as quickly as possible. And driverless AI helps us do that. And what driverless AI does is provide organizations an automatic machine learning capability in one single platform, allowing artificial intelligence to do artificial intelligence. It allows data scientists to build models more quickly. It allows it allows features to be created very, very quickly to drive accuracy, but it also allows the ability to understand those results incredibly quickly. So a number of you are asking about some examples and projects of people that are using AutoML. So let's have a look at some organizations that are really gaining massive value from using driverless AI. So let's have a look first of all at PayPal. And PayPal are using driverless AI around collusion fraud detection. Like many organizations, especially financial services organizations, machine learning isn't new, and they've been on a journey to apply machine learning to a number of business processes. And PayPal is one of those organizations, and they've been doing machine learning for many years and have delivered significant results. They were able, from their original fraud model, to generate an 89% accuracy rate. What they were able to do, though, within driverless AI, within a matter of hours, they were able to not only replicate 10 years of expert feature engineering that data scientists had spent lots of time and research developing, but they were also able to find new features that the data scientists hadn't even looked to consider, but actually helped drive an increased accuracy of identifying fraud. And they saw a 6% increase in identifying fraudulent activity. And they were able to run those models incredibly quickly because they were running driverless AI on top of a GPU infrastructure. And that helped them accelerate by over 6 times compared with their CPU architecture. So some real true value from PayPal there. We then move on to another financial services organization, that of Banco Vision. Vision Banco. What Vision Banco were doing were looking to increase the customer propensity to buy new credit products. And what you'll notice here are the themes of this use case are very, very similar. Again, with Vision Banco, they were seeing an increasing accuracy of their existing credit risk scoring processes in less time. What it's also enabled them to do is to increase their propensity to buy new products as well. And then finally, that of market access. With market access, what they were able to do was to build a bond pricing model that enabled them to, within real time, produce a prediction of what the price of 24,000 corporate bonds should be. But the reason that this is really interesting is because of the speed at which the model then executes. So they're rerunning this model every 15 seconds. And by having an up-to-date model that's looking at the relationships between the data and the predictions has enabled them to reduce their errors on average by about 66 cents per bond, which for them is worth a huge amount of money. And it's not just in financial services that we're seeing these performance gains. We're also seeing this across healthcare, we're seeing this across retail, and we're also seeing this in manufacturing as well. But what we also do is regularly take part in competitive machine learning competitions, like Google's Kaggle environment. In fact, we at H2O have, I believe, about 10% of the world's Kaggle Grandmasters working for H2O. And they are constantly using driverless AI and testing driverless AI within those competitions. And what we see is regularly we, with driverless AI, appear in the top 5% of those competitions. But the key big difference with us compared to maybe a Kaggler who's winning those competitions is every model that gets produced can be deployed into a production system within seconds, something that can't be done for the winning entries for Kaggle. And also, every single one of those models that gets produced will have full documentation of how that model was built, how that model was generated, what those key driving factors were, all generated at a click of a button. So hopefully what I've started to give you is not only the value of machine learning in financial services, but also the value of moving to an automated approach of building machine learning models and moving through different levels of that automation. But if you as an organization are looking to build up an automated machine learning platform or buy an automated machine learning platform, what are the key things that you really should be looking at? Well, the first one is can that automated machine learning platform automate the entire workflow? Can it be portable, and can it be flexible? And we'll start to sort of go into these points in a lot more detail in a minute. Also, what you need to think about is this platform extendable? So has that platform got the ability to add your own customizations from a data scientist perspective? And is it able to incorporate your organization's IP into the platform? And also, has it got the opportunity to give back to the open source community? So some of your thoughts and ideas, could you post those back into an open source environment to allow others to benefit from your thoughts? Does it provide you with a platform to explain your results, understand what on earth is going on in this black box approach to building a model? Does it enable you to build trust with external stakeholders and your customers? And does it allow you to be transparent with the decisions that you're making? Or is it, going back to an old sketch that I like in the UK, of is it just providing with you a computer says no answer? And does it provide you with a vision that will allow you to have a future-proofing solution? And those are really the 5 things that I and we at H2O believe that you need to be considering as part of that automated machine learning platform. So we need to make sure the entire workflow is automated. So that is feature engineering, it can be the model building, and it can be the model deployment side of things as well. And in those areas, you've got different things that you would want to automate. And as you see on this slide, there's quite a few of those. We look at maybe a level 2 approach. There's already a level of automation in H2O's open source AutoML package. So again, you're able to utilize that incredibly quickly. What you're also able to do within driverless AI is automate all of that. So that advanced encoding, apologies for that, that advanced encoding, the feature generation, the pipeline generation, the model explainability, and the model documentation. In terms of portability and flexibility, does your automated machine learning platform run on different environments? Can it run within the cloud, whether you've got an Azure strategy or AWS strategy or a global or a GCP or a Google Cloud Platform strategy? Can it run in both a private cloud and a public cloud? Can it run in a hybrid approach? Can it run on-premise, but then allow us to move to a cloud environment when it makes sense? And that's, again, what H2O allows you to do. Run on those different, but it also from any different data source. One of the challenges organizations have is their data is all over the place. Some of it's on-prem, some of it's in the cloud, some of it's in more text files. And what we need to do is to bring that all together. And within H2O technology, we're able to access any data from anywhere in any format. And with our partners, we can create that end-to-end solution, whether that be taking data that is entirely within the cloud and running all of the processing within the cloud, or whether we go with a hybrid model of cloud and on-prem, or we go with a completely on-prem environment. We at H2O don't mind where you do that processing. We want to be your automated machine learning partner. In terms of extendability, what we want to do is to give you the capability to extend our platform. So we believe we've created a great platform that gives you the ability to generate automatic features, select algorithms, and evaluate those algorithms against scoring functions. But your organization is different, and you will be wanting to use IP in all three of those steps and integrate that into your workflow. Whether that be custom feature engineering that is specific for your business problem, whether it's algorithms that you want to utilize that aren't currently in the driverless AI platform. So maybe a call out to the latest open source library that has just come out of academia. Or do you want to assess your models in a very, very specific way, centered around your organization? In the new version of driverless AI, you have the capability to do that, and also the capability to call on custom transformations and custom recipes and custom models that have been developed by the community. So all this is available within a GitHub repository. So this allows you to not only bring your own recipes, but also contribute back to other people's recipes as well, if your organization feels that there's bits that they do want to give back. If we think about explainability, lots of different components to it. So the challenge that we have with the explainability of automated machine learning models is a lot of the time you've got to have some sort of trade-off. You may have a very, very accurate model that's giving you fantastic predictions, but you have no idea how that model is making that prediction. However, by just sacrificing accuracy by maybe just 0.5%, you may be able to open up that black box of a model and understand more of the driving factors of that particular model. And this is where the human really comes into the automated machine learning process, where they're able to evaluate, well, what are the challenges of the business at the current time point? What's key? Is it accuracy? Is it interpretability? Is it how quickly that model updates? And working out where those trade-offs should happen. Again, one of the other challenges that you have with automated machine learning is you could generate a model that is not only just accurate, but is incredibly complicated. And that then gives you a bottleneck of when you then deploy that model. So it may be a very, very accurate model, but it takes 10 minutes to create one single prediction. Well, that works well when making strategic decisions, but it doesn't work very well if you're deploying this model for a real-time use case. So, for example, fraud detection. So again, a data scientist has to then be thinking about not just the accuracy, the interpretability, but also the speed at which that model is going to execute in production. If we're moving towards a world where decisions are being made automatically and machine learning models are at the heart of that, we need to make sure that those models are fair. We need to make sure that we're not discriminating around key fundamental factors. So social aspects of gender, age, ethnic origin, people's health, people's sexual behavior. But we also need to be really conscious that we're avoiding models that discriminate unintentionally. It may be that we've removed gender, age, ethnic origin as original features within our model, but the way the automated ML engine has manipulated other features is it's actually created proxies for those social aspects. So we really need to avoid those models that are discriminating but doing it unintentionally. And that concept is sometimes referred to as disparate impact. And we need to make sure that we've got that under control. There's still not a lot of trust in machine learning models to make automated decisions. And what we need to do is make sure in this whole area of explainability to make sure that we're building trust around these machine learning models. We need to show external stakeholders and people that don't understand the nuts and bolts of this particular discipline how this model will really work in the real world. What were the steps that we went through to build this model? What data sources did we look at? What were the restrictions of that data? Was the data biased before we actually built the model? Explain how that model was built, why it was built in a certain way, what other approaches were considered and why this one was looked at. Understand how that model can be debugged. And this is where really the human needs to really drive into that to help build trust around their art. As we understand more and more about how models work, the challenge that we then have is around the security of those models. Models themselves are in danger of being hacked, and models themselves are also in danger of being compromised. Fraudsters themselves can start to hack these models and understand how these models are making decisions. And if a fraudster knows how this automated decision is being made, they can manipulate the system to make fraudulent activity. And organizations need to be aware of that, specifically financial organizations. Constantly of how do we make models transparent, but also make them secure as well. And then also, which is really key with regards to explainability, is that around regulation. We've clearly got to work within the confinements of the regulators, but we also have to work with the regulators as well to prove that machine learning has benefit to the customers of financial services organizations, but they're also fair in the decisions that are being made. And then finally, with a great automated machine learning platform, is that it's future-proofed. So it shows that it's gone on this journey from first generation all the way through to where we really are now in terms of automated feature engineering and extensive model explainability, and then moving into some of those level 4 and level 5 concepts that I talked about earlier. So I just want to bring us back to the slide that I started with and go back to the comment that Mark Steen made at underwrite.ai. So not only can he reach a decision, he can also explain that decision. He can be fully compliant with the regulators, and it takes less than half a millisecond to do that. So what he's able to do is to reach that decision quickly. He's able to do that accurately, and he's also able to do that in a transparent way. So hopefully that's given you some food for thought and applications of AI and machine learning. If you do have any questions, then feel free to either pop a message in the screen that you see within your webinar. Feel free to connect to me on LinkedIn. So my name's John Spooner, and also feel free to follow H2O.ai as we look to help organizations move through this maze of taking data and creating value. So one question that has come in here is in terms of what is the roadmap of driverless AI to improve machine learning interpretability? That's a really, really good question. What we're doing is working with academia very closely to understand what are the latest and greatest interpretability research that's happening. We're already embedding a lot of that into our product portfolio. So we've got the ability to use a wide range of interpretability metrics, ranging from the simple of variable importance and partial dependency plots, all the way through to using K-line and Shapley values. What we're also able to do is not just do that for predictive modeling, but also do that for time series forecasting as well. And what we're also doing is investigating how do we move to the next dimension around unstructured data. So we've got the capability to do machine learning interpretability on unstructured data, so natural language processing. And the next part will be, well, how do we then do that with the next level of unstructured data, which is image data, and then video that. To your question around interpretability, in terms of, let me just have a look at some of the other questions that I've got. So, was the driverless approach tested in competitive machine learning like Kaggle? Yes, it is. It's done regularly by our Kaggle Grandmasters. Feel free to check out a website called benchmarks.h2o.ai, and that will allow you to see how we're benchmarking our products against some common Kaggle competitions. There's one question here that says, can you give an example of projects or companies who are at a level 4 or a level 5? Well, level 5 is easy. I personally don't think there's any organization currently at a level 5. There are people, there are financial organizations that's what they're trying to get to, but they're not there yet. Within terms of level 4, we are working with some development partners that I would say are at level 4. And the key with that is they're able to now accelerate on some of the newer features of our latest product, Driverless AI 1.7, that was released just a couple of days ago, that allows them to add in their own custom transformations. In terms of other questions that I've got, I want to make sure that I answer all of these questions for you. How the driverless approach performs against a manually generated model. Do you have a benchmark? Hopefully we covered that. Vision Banco and also market access of how we've actually generated a more accurate result. One question here in terms of availability of the webcast. Yes, this webcast will be available online to watch later, so feel free to retune on that. Also, if you do have any ideas of what else you would like to hear in terms of topics, feel free to, again, put those comments within your questions. So just in terms of the another response, so in your initial slide, you also mentioned cost efficiency. While talking about areas where machine learning has had an impact, can you elaborate a little bit more? So yeah, in terms of cost efficiency, really what we're seeing is a lot of people looking at how do we accelerate and make more use of our data scientists. Data scientists can be an expensive resource, and organizations are wanting to build more and more models. But the model of scaling out an empire of data scientists is just not cost effective. So by automating the process of building models, allow data scientists to become a lot more productive. So I think that's about it in terms of questions. So my name was John Spooner. I hope you enjoyed the last 50 minutes and look forward to speaking to you soon. Take care, everyone, and have a great day.